Okay, now we have some rational inequalities and we're going to solve these algebraically. And these are a little tricky because remember we have a rational expression, and remember when we want to solve the rational expression we multiply both sides by the LCD. In this case it's pretty easy because there's a 1 in the denominator here, so the LCD is x plus 1. So if we multiply both sides of an equation, it's no problem. But when we have an inequality, we have to be careful because remember, if we multiply both sides, or we can multiply both sides of an inequality by a positive value, and it doesn't change the direction of the inequality. But if we multiply both sides of the inequality by a negative value, we have to reverse the direction of the inequality. The only thing is, we don't know whether x plus 1 is positive or negative because x is a variable. If x is 2, it's positive. What if x is negative 2? It's negative. So we don't have any restricted domain on the values of x, so we don't know whether this is positive or negative. So we have to consider both cases. So we've got case 1. In the LCD, I guess I could say x plus 1 is positive or greater than 0. And case 2, x plus 1 is less than 0 or negative. All right? Now, it can't be equal to 0 because we can't have 0 in the denominator, so it's either going to be greater than 0 or less than 0. So we have those two different scenarios to deal with. So we just have to separate this and work out both. So it's like two problems. So let's say x plus 1 is positive. So I have my inequality. 4 over x plus 1 is less than 4. Then I can multiply both sides by the LCD, and it won't change the direction of the inequality. So I can say times x plus 1 times x plus 1. X plus 1 over x plus 1 is 1. So I have 4 is less than, and I can multiply this out, 4x plus 4. And then I can subtract 4 from both sides. We can do that. That's no problem. And I have 0 on the left is less than 4x. Then I can divide by 4. And I have 0 is less than x. And I can flip that around and say x is greater than 0. Because we usually see the x on the left. Now, this is all considering the case that x plus 1 is greater than 0. Well, if I subtract 1 from both sides, that means x is greater than negative 1. So it has to be both these cases. In other words, when x plus 1 is greater than 0, x is greater than 0, or x plus 1 is greater than 0 and x is greater than 0, or x is greater than negative 1 and x is greater than 0. So we have these two cases. X is greater than 0 and x is greater than negative 1. Okay, so we got these two different cases. And this is a conjunction. It's got to be both at the same time. So the way we can do that is we can graph this. And we've got 0 and negative 1, so I'll put these on my number line, 0 and negative 1. And first of all, x is greater than 0. So that's going to be over here, and it's got an inequality, so it's going to be, there's no equal sign, so I just have a circle over here. So those are all the numbers where x is greater than 0, and these are all the numbers where x is greater than negative 1. I guess I can put that over here. Well, actually, I should have done this like this. Excuse me. And these are all the numbers where x is greater than -1. And the numbers that we have both at the same time, and I lucked out, so I didn't have to rewrite this, where we have both happening at the same time, because it's a conjunction, I have to have two lines are starting from here all the way to here. So this is my solution over here. So this actually x is greater than 0 is my solution, because that's when I have two lines. That's when I have both conditions happening at the same time. All right, so I've got x is greater than 0. So that's one case. Now I got to consider the other case. So over here, in this case, I'll have my inequality 4 over x plus 1 is less than 4. And then I'll multiply both sides by my, I'm going to rewrite this because I'll need an extra step on this one. 4 over x plus 1 is less than 4. And then I'm going to multiply both sides by the LCD, which is x plus 1. But remember we talked about this before. The little trick we use is that when I'm multiplying by negative, I circle this as soon as I cross it, because I know the next time I'm going to write it, I'm going to have to reverse it because I'm multiplying by something that's less than 1. And x plus 1 is less than 1, so I have to reverse that direction of the inequality. So now I can simplify this. So remember, I'm multiplying both sides by a negative value. X plus 1 is negative. So I have to reverse the direction of the inequality. So as soon as I do that, I circle this. 1 over x plus 1 over x plus 1 is 1. So now I've got 4. But now I've got greater than, because I multiplied by a negative value. And I can distribute that. That's going to be 4x plus 4. And I can subtract 4 from both sides. A lot of your work will look the same because it's mirrored except the direction of the inequality. So I subtract 4 from both sides. So I get 0 is greater than 4x. And if I divide both sides by 4 again, almost the same work. Actually, it is the same work. Just the direction of the inequality is going to be different. I get 0 is greater than x. And that really implies that x is less than 0. But remember, we have this stipulation up here that x plus 1 is less than 0. That was our case situation. And that implies, if I subtract 1 from both sides, that x is less than negative 1. So this is another conjunction. We have to have this and this in this particular case. So we're going to graph that again. So this time I'll do a little bit better job on it, I hope. So draw my number line. And this is going to be less than, so I'll put a 0 here. And I'll put a negative 1. These are your x values, they should right. And the first one is x is less than 0, so that's this open circle, so it's going to be everything here. And then x is less than or equal to just less than negative 1. And it's a conjunction and this and this. And where do I have two lines? I've got two lines here. Not there, but everything past that. And if I look at that, that looks like x is less than negative 1. So my solution is either this or this, and this is a conjunction. This is a disjunction, or one or the other. So that's my solution. X is greater than 0 or x is less than negative 1. If we put that all in one number line to see it, we've got 0 and negative 1. We have x is greater than 0 or x is less than negative 1. Okay? So all these numbers would satisfy that inequality. So we have conjunction here, which is an and. I should write this over here. X is less than 0 and x is less than -1. So these are conjunctions and this is a disjunction or. So here we just have to have one line or the other. Here we have to have two lines for a conjunction or an and statement. Okay? So it's a pretty challenging problem, so take a look at that.